Welcome back, Physics 30. This is the FI1 Gravitational Fields Review to let you know what is on the upcoming exam. So there's only three sections here: FI 1.1, Newton's Law of Universal Gravitation, FI 1.2, Gravity Near the Earth's Surface, and FI 1.3, Satellites and Weightlessness. So this one will have 7 multiple choice questions for 7 marks and 4 short answer questions worth 20 marks, so equaling a total of 27 marks for everything. So to give you a hint of what those 4 questions will be, we have number 1, determine the force of gravity, Fg, being exerted on a satellite a certain distance above the planet. So you will have an updated formula sheet here. So it has everything up until the end of FI 1.1. So if you go to the flip side here, here are CO2 equations, and here we are the new ones. So Fg, there it is right there, mass of Earth, mass of object, or whatever those two masses are. I just put ME if we are pertaining to Earth, in which we're using the Earth's mass and the Earth's radius plus the altitude. And big G, of course, the universal gravitational constant, 6.67 times 10 to the minus 11. So that's how we use that. Just be careful. Take a look at the 2 objects in question of what we're using, if it's Earth or if it's some other planet. Okay, so that'll be the first question. Number 2, determine the acceleration of gravity due to a certain distance above the Earth's surface. So we're looking at maybe a satellite or something that's hovering above the Earth. So of course we have this, determining G. So of course the surface of the planet, G is 9.80 meters per second squared, but how much is it a certain distance above? And one thing to note here, the R here and the R here is the radius or the distance from which the object is from the center of the Earth. So recall that this R is equal to RE, the radius of the Earth or the planet, whatever the object is, plus the altitude, how far it is, because the distances or the R value is always taken from the center of the Earth to where it is at above the Earth. Number 3, determine how fast a satellite must travel in order to maintain a certain orbit. So remember, a satellite has to travel a certain speed in order to maintain that orbit so it doesn't leave the orbit or be less than the orbit and hit the Earth itself. So looking at the velocity it must have, so yes, the only thing that you need to consider is the mass of the object that's rotating around. Most of the time we're talking about Earth. And again, that R value, the radius of the Earth plus the altitude. And lastly, the last thing we did, determining the apparent weight in an object. Determine the apparent weight an object, that should be and weight an object experiences when it is moving with constant velocity or accelerating a certain distance above the Earth. So we did a bunch of elevator examples. You could look back and see how you did that. And most of it, of course, involves the material on this page here. So it's kind of like this equation, F net, except we're looking at it vertically. So you have F net plus Fg plus W. So I don't have that written down here. You may want to insert that somewhere on here so you have it. And looking at what the apparent weight looks like when, of course, there's scenarios in which we're moving with constant velocity or accelerating upwards or accelerating downwards. When do we get a larger weight or less weight, apparently, etc. All right, so that's the review. You should be ready to do the exam once you go through those questions and look back in your notes. All right, we'll see you again.